right. Just took a look at quiz 7 and a little bit more of a challenge for the students as a whole in here. So if that was true for you as well and you're watching, as I told them, don't throw that quiz away. Set it aside with whatever corrections or markings there may have been on it. Make sure that you learn from that, since we have an exam coming up in Lesson 44. That'll be this Friday for students in here. Lesson 44 will be our exam. It'll be over chapters 1 and 2. We're almost done with chapter 2. We're going to be wrapping it up maybe tomorrow, probably halfway through the hour Wednesday, and then have about a period and a half just for review. But for homework over the weekend, you did page 90, numbers 1 through 13. Have that homework out, and let's take a look at that. And the first part of the homework was our new concept we had gone over. I say new, it wasn't really that much of a new concept. You were still finding percent. And remember, class, to find a percent, you make a fraction. That was kind of weak. Class, to find a percent, you have to make a fraction. Because that's what a percent is. It's another way of showing a fraction. So make a fraction. Put the part over the whole. But more specifically, in this case, we were finding specifically percent of change. And we want to find percent of change. I said there's a key fraction you need to memorize. To find percent of change, percent of increase, percent of decrease, however they want to call it, to find percent of change, class, what is that fraction? Change over original. Class, how do we find percent of change?
Change over original.
Good, water bottles on the floor. One more time, to find percent of change, class.
Change over original.
Now here's the key. Most of the time, they won't tell you what the change is. You have to find it. But every now and then, they're sneaky. And they tell you the change just to try to mess you up. So make sure every problem you go in thinking, what fraction, class?
Change over original.
Don't just go in there automatically subtracting, because there will occasionally be a problem where you should not subtract. They've already given you the change, and they're just trying to mess with you, okay? Don't let that get you. You make sure you think, what fraction, class?
Change over original.
Change over original, and make sure you actually think, what is actually the change here? Did they already tell me? If so, why would I do more work? If they didn't tell me, okay, I have to actually do the work. For instance, on number 1, did they tell us the change, Elaine?
No.
No, we had to find the change. So I don't know what this is. Maybe this is shirts sold. I don't know. Maybe this is like Spirit shirts or something. But originally 88 shirts sold. Then later on to only 66 shirts sold. What's the change?
22.
22. We put that over the original.
88.
I would reduce that down, and it reduces pretty nicely.
1/4.
1/4, which is what decimal?
0.25.
Which is what percent?
25% decrease.
Okay, you answered my next question, 25%. The next thing they wanted was for us to indicate, was this an increase or a decrease? But class, were things going up or going down? Down. That things decreased here. So how many had the 25% decrease for number 1? Questions on 1? Number 2, original 21 apples, final 28 apples. I don't know, maybe one year you go to, we don't have apple orchards really down here much to speak of. Up north they do. And maybe shout out to the McDonald's. We miss the McDonald's. Most of you, some of you don't even know who the McDonald's were because you're new students this year. But most of us, we love and remember the McDonald's. And so maybe they go to the apple orchard and Haley picks 21 apples. And then the next year she's more ambitious and she picks 28 apples. And her dad loves that because the more apples you pick, the more you have to pay. But anyway, what is the change? Does it already tell me the change here, Jalen?
No.
No, we have to find the change. And what is the change?
10 is 7.
7. And then we put that over the original, which was?
7 over 21.
21. We got to reduce that down. And 7/21 reduced very nicely, Jalen.
1/3.
1/3. We might have this memorized because remember, this is one of those percents that we have to actually use the fraction. What did you put, Jalen?
33 and 1/3%.
There we go, 33 1/3%. Now, if you didn't have that memorized, you at least know it's 0.3 repeating, which, since it did say you could round to the nearest whole percent, you could say just 33%. Make sure we keep our feet still. 33% we could put, but I actually like the 33 1/3% because it helps us remember these two go together. Was that increase or decrease?
increase.
Increase.
Honestly, I put 33% because I forgot to put the 1/3.
Well, again, and they did say nearest whole percent. So if you put 33%, that is not a problem at all. That is absolutely correct. That's what the answer key has. I would like us to begin associating those two numbers together, but it's not a problem, mainly because when you see this, I want you to think 1/3. Not so much the other way around. So, no, if you had 33%, that is not wrong. And it's 33% increase because Haley picked more apples this year than she did last year. Questions on number 2? How many had number 2? You had the 33% increase. All right, looking at number 3. There were 13 players on the team last year, and then this year there are 15 players on the team. And let's see, guys, who's going out for the basketball team here? Got a few. Let's see what Sam. Does it tell us the change?
We're on number
Sam,
3.
we're on number 3. Pay attention, boy. Let's see. So what's the change here, Sam? Hush. He can figure it out. He's a smart kid.
2 over 15.
Well, the change is what? How many more, what's the difference in players? From 13 to 15, what's the change? 2, there we go. Don't overthink this. The change is 2, right? They had 13, now they have 15. That's a change of 2. Which is the original number?
13.
The 13. That's going to be our fraction starting out. The change over the original, 2 over 13. That doesn't reduce. And that ain't one we memorized. So class, what are we stuck doing here?
Divide.
We're stuck dividing. Now, in the division house goes which number, Sam?
2.
The 2, the top number, right? The general goes in the house, and the lowly private at the bottom of the barrel, so to speak. He's got to stand guard outside. We're going to need to put what at the end of the 2, class? 0.000. Give yourself a few decimal places so we can round, and we're going to start with, well, how many times does 13 go into 20, class?
1.
Once, right? And that, when we subtract away the 13, that leaves us with 7. Let's bring down the 0. 13 into 70. How many times do you think, Sam?
Probably like 5.
We want to try 5. You're like, I trust Bryson. He's a smart guy. 5 times the 3.
15.
Carry the 1. 5 times 1 plus 1? 6. And hey, that worked out pretty good. He is a smart guy. We subtract, what do we get, Sam? 5. And we bring down a 0. Is 13 going to go in 5 times again? No, it's going to go in less. It might be 3, it might be 4, but it doesn't matter because it's less than 5. And if it's less than 5, class, is it going to bump this up? No. So I don't even care what it is. My answer is going to be what, Sam? 15%. And is this increase or decrease?
Decrease? No, increase.
We start with 13 guys on the team, and the next year we got 15. That's going up, right? So that's an increase. How many had 15% increase on this one? Questions on number 3. Jalen. Number 4. 25 flags. Maybe this is like a flag display. How many of you, your church around 4th of July puts out a whole lot of different flags around the property? Our family, we used to do that. We got free flags from the church. Every year we get a new flag. And so we just kept adding to our stash of flags. And we'd have flags all along the driveway and stuff. And we kids enjoyed decorating for 4th of July. And then one year it rained, and they were cheap plastic flags, and so the printing on the plastic ran, and it ruined all our flags, and we went way down in the number of flags. Well, this particular whatever, there's 25 flags out on display, and then later on there's only 22. Maybe people came by and stole 3 of the flags. Thieving patriots. Or maybe some of the flags broke or got damaged. They realized they didn't look as good, so they decided not to keep them. Either way, what is the change, Griffin?
3.
What's the original? 25. Now, that's not something I've memorized, but there is a good shortcut to get to a percent here.
Divide.
I could divide. I don't want to. There's a better way. Percent means what, class? Hundredths. Does that clue remind us of something after a weekend?
Money. Yeah, I think I'm money right now. I'm like,
What could I do here, Michael?
You can multiply by 4.
Multiply top and bottom by 4 to get that hundredths denominator, right? How many hundredths back to Griffin now?
1200.
12 hundredths, which becomes 12%. Would this be increase or decrease, Griffin?
Decrease.
Decrease. A few of the flags lost. Sadness and sorrow. How many 12% decrease on number 4? Number 5. Oh boy. Well, actually, maybe this is a good thing. Maybe there are 150 bicycles at a bicycle store, and they have a big sale, and when the sale is all said and done, there's only 15 bicycles left. That's a good day, right? That's selling a whole lot of bicycles. And so we want to find the percent of change. Does it tell me the change, class? No. What if, listen, what if it said a bicycle store had 150 bicycles, but they sold 15? Would that be telling you the change? So we wouldn't subtract then, would we? But it didn't tell us they sold 15. It tells us they had 15 left by the time it was all said and done. So they did not tell us the change. We have to find the change. What is that change, Bryson? 135 bicycles is the change. What's the original? 150. I definitely want to reduce here. I can at least divide a 5. I don't know if I can divide more, but I can at least divide a 5 out of this. Let's start with the bottom. It's easiest to divide 150 by 5.
10. Oh no. 30.
30. And then the 135 divided by 5. Class, let's see. 5 goes into 13 how many times?
2.
2 times. With how many left? Class? 3. 5 goes into 35, class. 7 times. Oh, I can reduce that even further, and I think you did because of what you said a moment ago. I think you divided a 3 out, didn't you?
Yes.
To get
9/10.
which what is that 9/10 as a decimal?
0.9.
0.9, if we go boink, we get what percent?
90%.
90%. Now, would that be an increase or a decrease here, Bryson?
Decrease.
That would be a decrease. Now, it's a great thing if that's how many, if they sold all those bikes. They sold 90% of their stock, but 90% decrease is our answer. How many have that for number 5? Number 6, a storm started with a wind speed of 35 miles an hour, and an hour later, the wind speed was up to 70 miles an hour. There's some warm water in the Atlantic maybe, and that storm picked up speed very, very quickly. We need to start by finding the change. Ben, what's the change on number 6?
35.
35. It went from 35 to 70. That's a change of 35 miles an hour. We're going to put that over the original, Ben. 35. Well, class, anything divided by itself is 1, which as a percent, Ben, would be 100%. Now, would that be increase or decrease? Increase. How many got 100% increase? That's kind of a weird one, and its weirdness could have thrown you off. It was super easy, but its weirdness could have thrown you off. Questions on number 6. All right, again, we did not get a chance to do a lot of this in class. But how many, regardless, were perfect on 1 through 6? You got all of the percent change problems. How many got 5 out of 6? You only missed 1 of them. How many are glad we're going to be doing some more practice with this here in a little bit? All right, good. Do we feel like we understand a little bit better now? Find the change, put it over the original, make a percent. Yes, sir.
Do we just, every single time we do one of these problems, do we just always put it over the original?
That's the formula. Change, I say formula. It's not much of a formula. It's a practice, but change over original, always. Yes. Now, sometimes it doesn't necessarily say original final. Like on 1 through 5, they did. On number 6, you had to kind of read between the lines and figure it started at 35. Okay, that's the original. Right. Elaine, question.
For number 6, I put 50% increase.
Try to do it in your head too quick. Or will you guys put the 35 over 70?
I think that's what I did. Yeah.
All right, yeah, the 35 was the original, so 35 35ths. 35ths. All right, any other questions 1 through 6? Number 7, a little bit of review on discount and sale price. Remember, class, discount is what you don't have to pay. The sale price is what you do pay. And it says we got a $105 jacket. That's an expensive jacket. And it's on sale for 35% off. This is clearly not a jacket I am buying. But it's on sale for 35% off. How much was the discount on the jacket? Corey?
$36.75.
And all we have to do to find that is do what, Corey?
Subtract.
Boo, boo, boo. All we had to do to find the discount was
To multiply.
multiply the 0.35 times the $105. No big deal. $36.75. To find the sale price, Corey, that's when we need to subtract. And what was the sale price?
$68.25.
Good. When you take the $36.75 that you don't pay away from the $105 that they originally wanted, it leaves you paying $68.25. How many got both of those answers correct on 7? Questions on that? Number 8, finding percent. Now this is not percent of change, it's just finding percent. Class, to find a percent, you make a fraction. which can then turn into a decimal, which can turn into a percent. Class, to find a percent, you make a fraction. On number 8, what is the fraction page?
20 over 50.
20 over 50. Now let's reduce page to get
4. 2 over 5.
2/5, which is what decimal?
0.4.
0.4, which boink, boink, gives us
40%.
40%. There we go. We aren't labeling this as increase or decrease or anything because there wasn't anything like that. It's just 20 is what percent of 50. Number 9, what fraction do we have to start with, Bryson?
60 over. No. No.
What's the whole? 210 is what percent of 60? The last number, call that base, remember, class. That's your whole. That's what goes on the bottom. So you're right. You're like, but it can't be, because 210 is bigger than 60. Right, it just means you're going to get a percent over 100%. So yeah, your initial gut, I think, was to say 210 over your 60, but that can't be right. It is. 210 is the part, 60 is the whole. For instance, 60 minutes in an hour, right? Well, let's suppose it took you 210 minutes to run a marathon. Well, that's obviously more than, by the way, the world record just got broken this past weekend. I believe it was 2 hours, 35 seconds. It's insanely fast. Some guy from Kenya there whose name I can't pronounce. But anyway, new world record in the marathon. Be thinking of him while you do your 12-minute run today. All right, anyway, no, you don't have to run that fast. But let's suppose it took 210 minutes to run that to run that marathon. Well, that's 210/60 as if you're trying to put it in terms of hours, right? So that's still acceptable. It just means you're going to get something bigger than an hour, right? You're going to get something over 100%. What do we need to do to reduce here?
Divided by 10.
Let's knock off the zeros first, and then let's further reduce.
7 and 2.
7/2. Now, 7/2. What is that as a mixed number?
14.
2 goes into 7 how many times? 2 goes into 7 how many times? Is that nice, Ben? Class? 3 with how many left over, class?
1/2.
So 3.5, right? Brain freeze. It's been over after the weekend. We know how to do this. We've done it before. We did fine with it earlier. But let's make the half class a decimal. Not 3.5 class, but 3.5. And then if we go boink, boink, we get what percent, Bryson?
35%.
Oh, boink,
Alright.
boink.
Yeah. 350.
350% is correct. How many got 350%? It's more than 3 times as big, right? That's what 300% would mean, is 3 times as big. This is more than that, it's 350%. Number 10, basic addition problem. What did you get, Luciana?
145.64.
Good, 145.64. Number 51, basic subtraction. We got to be careful with the decimal then.
46.378.
46.378. Number 12, multiplying. How many decimals going to be in the answer, class?
4.
4. We got 3 in the first factor, 1 in the second factor, so the product is going to have 4. What was our answer for number 12, Michael?
151.2324.
Good, 151.2324. And then number 13, we can't really divide by the decimal, class. What do we have to do before we can divide? Boink. Over just the one place. Make it a 15 outside the house, make it a 7,020 inside the house. What do we get on 13, Elaine?
468.
468 is correct. Questions on the homework? Yes, ma'am.
It's not really a question, but on number 8, I only said decimal because I was looking at a decimal point.
Ah,
I
okay.
meant to say fresh.
All right, that's okay. Question?
Can you show 13?
Show number 13. Yeah. So we've got the, remember, the first number is what is being divided. The second number is what goes outside. So that's the first thing, right? Make sure we set it up correctly. Move the decimal over one place to here. Move the decimal over one place to there, right? So move that decimal over once in each case. And you say, okay, 15 into 70. I don't know. Maybe you try 5 times and find out that's 75. Okay, that's too much. So we go with 4 times. That's 60. Subtract, and you say, I don't know, maybe 6 times? And find out, yeah, that works, that's 90. That gives me 12 left over. I don't know, 8 times? And 120. And if you tried something other than the 4, 6, and 8, right, you just figure out it doesn't work, so you go with the next number, and you're probably only going to be 1 off. So that's all we got to do there. Any other questions on the homework? Flip back now, if you would, to page 88. Flip back to page 88. We did 1357. on page 88. I want you to do 2, 4, 6, and 8 on page 88. 2 through 8, the even. Find the percent of change. Again, what's our fraction class? For percent of change?
Change over original.
Stay with me. I know it's a Monday. Stay with me. Change over original. So we got to figure out what is the change and put that over the original. Do numbers 2 through 8, the evens. Finish early before I call time, go back or go ahead to the next page, the top of the next page, and be working on the problems up there. Just about another minute or so to be working these 4 problems. Again, if you finish early, go to the top of page 89, be working on the 9 through 14. All right, for sake of time, pencils down. Even if you're not finished with all of these, let's take a look at number 2. What's the change going to be on number 2, Luciana? 7. What's the original?
70.
What does that reduce to?
110.
Which as a decimal is?
1.
0.1, right, to tens place, which when you go boink boink gives you?
10%.
10%. Would we call that increase or decrease? Decrease. How many had 10% decrease on number 2? Number 4. What's the change page?
2,
What's the original?
16,
What does that reduce to?
180,
What is that as a decimal?
0.125.
And when we go boink boink, it gives us
12.5.
12.5. 12.5. We're finding percent of change. There we go, 12.5%. And is it increase or decrease?
Increase.
Increase. There we go. Now, if you rounded to 13% like the directions said to do, that's fine. When it comes out nice like this, I just assume leave it as 12.5 or 12.5%. And we have that for number 4. Number 6. Ooh, what's the change going to be here? Sam?
32.
32. And the original?
16.
16. What does that give you when you divide?
I didn't divide, I just knew 16 times 2 is...
So in other words, the answer is 2.
2, yeah.
Right? 32 sixteenths is just plain old 2. But then I still have to go boink, boink, Sam, so I get 200%. And is that increase or decrease?
Increase.
It is increase, 200% increase. How many have that for number 6? Number 8. Let's see, what's the change then?
3.
On number 8, Ben, what's the change?
2.
2. And what's the original?
16.
On number 8?
Oh,
Ben, pay attention, boy.
10.
10. 2/10, which as a decimal would be what? 10th place, Ben, 10th place. 1 decimal place, so 0.2. Right? 3/10, 0.3, 4/10, 0.4, 5/10, 0.5.
And you can reduce it.
I don't need to, it's already 0.2. Now, could I reduce it to a 5th, which is also 0.2? Absolutely. But if it's tenths, tenths just means 1 decimal place. But then we gotta go boink boink to get
20%.
20%. Is that increase or decrease?
Increase.
That is increase. There we go. So you found 2 more pens on the floor. Instead of having 10 pens, you now have 12. How many 20% increase on number 8? Let me give you the answers to 9 through 14 very quickly. You can either go and work these later, or if you've already worked them, be interested to see what you got there. Number 9 should have a 60% decrease. For number 10, have, let's see, 12.5% decrease, or 13% decrease if you rounded. Number 11 is a 100% increase. Number 12 rounds to 13% increase. That one was kind of annoying. Number 13 is 700% increase. And number 14 is about 6% decrease when you round to the nearest whole percent. Anyone who already did some of those 9 through 14 have a question on any of those? Michael?
I don't have a question, I did anyway.
Oh, all right, anyone do some of those, and all the ones you did, you got right? All the ones you did, you got right. Any questions on the 9 through 14? Elaine?
On number 13, I had, for some reason, 710% increase.
What's your change, let's see, 480?
No, that's it.
Okay, yeah, the change should have been 480, and we put that over the original, which was 80. Knock off the zeros, 48 divided by 8 is 6, and then boink boink, there's our 6. Great. 560, I can't subtract him, I was trying to subtract, that's 560. I don't know where my borrowing was. Let's pretend that never happened, shall we? 640 minus 80, borrow. 14 minus 8 is 6, 5 minus nothing is 5. 560 over 80 should give you 77, which is 700%. That was bad. All right, it's a Monday for me too. All right, Jalen?
So what did you say, number 11 was?
Number 11 is a 100% increase because the change is 500. The original is 500, which gives you the 100%
I got
increase.
that right.
Good. All right. Any other questions on the 9 through 14, Corey?
Can you do number 12 and
Yeah. So what's the change, Corey, on number 12?
8,
8, and the original is,
63,
which is just obnoxious because you can't reduce it at all. So you're stuck putting the 8 in the house with some decimal places after it, and a 63. 6 goes into 8 once. Obviously, that 63 gives us 17. 6 goes into 17 twice, which is 126 there. We subtract, we get 44. 6 goes into 44 7 times. And, oh, it just misses, right? So it's actually a 6, but it doesn't matter. 6 or 7, it's going to bump that up to a 13%. All right, good. Anything else? Let's take a look at the word problems. Read number 15 for us, if you would, please, Griffin.
15.
Yes.
A store sold a jar of applesauce for $1.50. 1 week. The next week, the same store sold the same brand and size applesauce for $1.65.
Alright, so what's the change here, anybody? Went from $1.50 to 15 cents, 0.15. And what was the original here, class?
$1.
Started at $1.50, didn't it? Now, right off the bat, what can I do with the 2 decimal places in the top and bottom, class? Move them out. As long as what you do to the bottom, you also do to the top, right? It's basically you're multiplying top and bottom by 100. Let's make it 15 150ths. Does anyone see that you can divide a 15 out? What do you get if you divide 15 by 15? 1. What do you get if you divide 150 by 15? 10. What is 1/10 as a decimal? 0.1. Then if you go boink boink, you get 10%. And that's 10% class increase. The price went up. Number 16. Read that one for us if you would. Paige.
For the fall semester, Faith Christian School had an enrollment of 520 students. The spring semester enrollment was 550.
All right. What's the change? Anyone? 30. What was the original? 520. Let's knock off the zeros. I can't do any more reducing, which means I have to divide. Paige, what goes in the house?
52.
Oh, in the house.
3.
The top number, 3. And what should I put after the 3, Paige?
0.000.
And then outside the house, we'll put the
52.
52. 5 goes into 30. How many times, class? 6. But you see that 2 is going to mess that up, isn't it? So it's only going to work 5 times. Now notice, there's 2 digits here, 1, 2 digits here. I'm going to need to put the 5 over the second 0. 5 times 2, class. 10. 5 times 5 plus 1, class.
26.
What do we get when we subtract? 40. Bring down a 0. How many times 5 go into 40, class? 8, but that 2 is going to mess it up, isn't it? So I'm only going to get, doesn't matter, 7 or 8. What's it going to do to the 5, class? So I'm going to get what for my answer? 6%. Is it increase or decrease, class? Increase from this fall to the spring semesters. Number 17, read that for us if you would. Bryson.
Ava usually walked 20 miles a week. This week she walked only 18 miles.
All right, and sounds like your endurance run today. Just kidding, it's not that long, it's barely a mile. All right, so what's the change, class? 2. What was the original? 20. What does it reduce to?
110.
What is that as a decimal?
0.1.
0.1. Point gives us?
10%.
10%. Is that increase or decrease, class? Decrease. She's going from her usual 20 miles down to only 18, so decrease. Read number 18 for us, Jalen.
Usually Anna works 36 hours per week. However, last week she worked only 28 hours.
All right, what's the change, class? 8. And what's the original? 36. I can reduce a little bit. I can divide a 4 out, class.
2 9.
Ah, wait. Ninths? What is that going to be? 0.2 repeating, right? So if I go boink, boink, class, it gives us 22%, or 22.2 repeating percent, or 22 and 2 ninths. It did say nearest whole percent anyway, so we could leave 22%, though this is more accurate. And would that be increase or decrease, class? Decrease. She was not able to work as many hours. I don't know if she got sick or life just got busy, but decrease in the number of hours. Number 19. Read that for us if you would, Luciana.
Kevin had 75 stamps in his stamp collection until his cousin Jay gave him 10 more stamps.
What's the change, class?
10.
10. Look at it again. I told you they were going to try to trick you. What's the change? His cousin gave him 10 more. He doesn't have 10 now. He has 10 more. Do you see that the 10 is the change? What's the original, class? 75. I can divide by 5 at least. 2 and 15. I don't know if that helps at all, honestly. Whatever, all right, here we go. I don't like having to divide. I like it when we already know the decimals. By the way, that's why we memorized them. So this would be easy stuff. 15 goes into 20? Once. If I subtract the 15, how many left?
5.
5. Think of time on the clock. How many 15-minute periods are in 50 minutes?
3.
3 of them, but 3 times 15 is actually
45.
45. Subtract to get
5.
5, bring down a 0. How many times 15 going to go into 50? 3 again. It's going to keep being 3s, isn't it? Doesn't really matter though, because I'm only rounded to 2 decimal places.
13 and 1/3.
13 and a third percent, if you wanted to put that in there. Nice job, Michael. 13% I would certainly take. Increase or decrease, class?
Increase.
Increase, because he now has more stamps. Do you see what to watch out for? Stay sneaky. Number 20. I'm going to read that for us. Let's see, Michael.
Last year, 830 people attended the local fair. This year, 780 people attended.
What's the change, class?
50.
50. And what's the original here?
830.
830. And we can easily knock off the zeros, and that's not anything I recognize, which is annoying again. Be careful here. 8 goes into 50, class. How many times?
6.
8 goes into 50 6 times. Now, that's because I'm just looking at the 2 digits, so I am going to have to put a 0 here. Let's try 6 times 3, class.
18.
Make sure we're lining up here with the third digit. 6 times 8 plus 1.
49.
And when we subtract, we only get 2. Can 83 go into 20?
No.
It doesn't matter what comes next. I'm going to round to almost exactly. 6% class.
Increase.
Decrease. Fewer people came to the fair this year than last. Questions on percent increase, decrease. Do we see how to tackle them? Find the change most of the time. Sometimes they may give it to you. Put it over the original questions. Last thing that we need to talk about before your test, introduce it today, practice it more tomorrow, is finding the base, right? Page 90. Finding the base. And put this there next to it, if you would. Finding the whole. W-H-O-L. Finding the whole. W-H-O-L. W-H-O-L-E. There's an E at the end. I can't spell. All right, finding the whole. Okay, just trying to emphasize this, the W at the beginning. Finding what is the whole amount. For instance, let's suppose that, I don't know, Corey is in a generous mood, and Corey has some money, and he has 5 friends in the class. He says, I'm going to give each of you $4. Right? So there's 5 of you, you each get $4. If you each get 1/5 of his money, 4 is the part, 1/5 is the fraction you get. How much did he apparently start with, class? Okay, $4, $20. Good, Corey. Okay, class. $4 for some guys. Each guy gets 1/5 of his money that he's giving away, right? There's $4, and $4 is 1/5 of what? 20, right? Okay, let's try something easier. Let's suppose I said this. 9 is half of what? 18, right? If I said 9 is half of what? The what here you realize is the total, the whole, W-H-O-L-E, right? How would you figure out 18, class? You multiply 9 times what?
2.
Times 2. But when Jalen said divide head offhand, she wasn't wrong. Because if you said 9 divided by 1/2, that is 9 times 2, isn't it? But you divide the ratio. We know that means multiply by the reciprocal, but you divide the ratio. What's another way to say 1/2 if I were to use a percent, class? 50%, right? 9 is 50% of what? Well, 50% can become a decimal,
0.5.
0.5. And if I were to take 9 and I divide it by 0.5, 9 divided by 0.5, and then move the decimal over once, I would get 18. That's how you find the total. You divide the part by the percent, changed to a decimal. Divide the part by the percent, right there in the side margin. Divide the part by the percent. Now the part, of course, we call the percentage, So we're dividing the percentage by the percent. But I think an easier way to think of this is to divide the part by the percent. Look at their example here. 16 is 25% of, now how do we get the 64? You take the 16, that's the part, divide it by 25%. But notice 25% gets changed to class 0.25. It's right there in your textbook, people. Wake up. Pay attention. Looking in your books. Page 90. 16 is 25% of...
64.
But how did they get the 64? They took the 16, that's the part in red. They divided it by the 25%, written as... It's right here in your books. I'm sorry if I'm losing patience with you, but you deserve to be gotten onto. 0.25. The part, written as a decimal. Listen to what I'm saying and engage your brains, please. Even on a Monday, engage your brains, please. 16 divided by what decimal, class? 0.25. Here's the problem. Can we divide by a decimal?
No.
No. So strategy tip. When you get to this point, move the decimal here and here. Rather than wasting your time even writing it this way, just start with the 1600 divided by 25 and you'll get the 64. Look at the next page. There they show it again. 16 is 25% of what number? They change the 25% to class 0.25, and they divide the 16 by the 0.25. Now in their case, rather than making the fraction first, which is what I would suggest, they went straight to division house. I'd prefer the other way. But you know there's another way they could do it. What fraction is 25%, class? 1/4. 16 divided by 1/4. 16 times 4. That would have been an even easier way. Sometimes you can do that. Look at letter B. Read letter B in the example box for us, if you would, please. Elaine?
Yeah. There are 12 girls in Mr. Cooper's class. The girls make up 40% of the class. How many students are in the class?
All right, we're going to take the part and divide it by the percent. How do we show division, class? Fraction bar, right? Let's start there. We're going to take the part. Well, the part class is the girls, right? Girls are a part of the class. What part are girls' class? 12. And it says it's what percent? 40%. This is what you're doing. Though you won't write this. Instead of writing 40% class, what will you write? 0.4. Now here's the key. Can I divide by a decimal, class?
No.
So simply move the decimal over one place, but what you do to the bottom? Gotta do the top. So this becomes what new fraction then, class? 120 over 4. I can do that in my head. 4 goes into 12. 4 goes into 0. We're done. Look at problem number 1. Read number 1 there for us, if you would. Paige?
42 is 3% of what number?
What fraction will I make, class?
42 over 3.
Not over 3. 0.03. And then what do I have to do with the decimal, class? Boink, boink. But if I do it in the bottom, boink, boink. So really, class, I have 4,200 over 3. Let's do what we call short division. 3 goes into 4 with 3 goes into 12 with
0.
3 goes into 0? 3 goes into 0? There's our answer. Do this next one with me. Write in your book as I write. What fraction should we write first of all here? Corey?
50 over 1.6.
Good. How many thinking the same thing Corey said? 50 over 1.6. Now, what do I have to do with that decimal, class? Gotta move it. In the bottom and in the top. So this becomes what new fraction, Corey?
500 over 16.
I don't know that I'm too good at reducing that one, so let's go ahead and divide it out. 500 divided by 16. How many times do you think 16 would go into 50?
3.
4 would be 64, so let's try 3. 3 times 6.
18.
And 3 times 1 plus 1.
4.
Hey, if you said 4 and found it was 64, that's okay. You need to go with 3 the next time, so it's no big deal. 50 minus 48.
2.
Bring down a 0 here. 16 goes into 20. 1. So we can do this in our head. How many left over, class? 4. Hey, wait a second. 4/16, right? I know what that is as a fraction.
1/4.
1/4. 31 and 1/4. Or you could add a decimal, bring down a 0, it goes in twice, with 8 left over, add another 0, goes in 5. You can get 31.25. I just assumed it the 31 and 1/4. The key is make the correct fraction. Number 3, what fraction should we set up here? Ben, stay with me.
2,637 over 5.5.
Or class, instead of 0.5, I could write what? 1/2. Because if I divide by a half, we know that dividing, class, is really multiplying by the
Reciprocal.
So really I could just multiply this by
2.
2. At your seats, multiply by 2. Call it when you've got it. Call it.
Oh, 5,274.
5,274. One more, I'll let you go, but I want to make sure you're going to know what you're doing on your homework. Number 4, what fraction do I write? Bryson.
132 over 0.25.
Make sure we write this in our books because we're going to be able to use this for reference as we do our homework later. But 0.25, what is that as a fraction, class?
1/4.
And if I know that it's 1/4 and I don't really divide, class, we multiply by the reciprocal. I could change this to 132 times 4 at your seats. Do it, call it when you've got it.
528.
528. It's a Monday, isn't it? 528. Do we see what we're doing to find the whole? Take the part that they give us, called the percentage, divide by the percent. Either make it a decimal and use it that way, or if you can make it a fraction, that might make your life easier. For homework this evening, you are going to do page 92, numbers 15 to 22. Page 92, numbers 15 to 22. And I lied, you're actually not going to have any of these in the homework tonight. We're going to save the practice for tomorrow. I did not realize that at the time. But yeah, page 92, 15 to 22. It's going to be in the review section rather than the homework section. All right, have a wonderful rest of your day. You are dismissed.